Okay, so hopefully you found that okay.
Oh.
No, who said that? um, so if not, follow along. It was pretty quiet on the chat. So I'm hoping most of you are relatively right. But if not, as I say, do follow this along, and I will make all these solutions available as well, so you'll be able to look through the solutions in your own time. So the first task asks you to write a piece of code that asks the user to input a number and then prints out the times table from 1 times up to 12 times the number. Up to and including is the key here. So first of all, in this, I've got a variable called chosen number, and I store into that an integer casted input from the user, asking them to input a number. Then what I do is I say for x in range 1 to 13, because I want to start at 1. I don't want to start at 0, which it will if I don't put a starting number. But I want to go up to and include 12. So I need to put 13 there so that it does that. Otherwise, it'll only go up to 11. And then within the for loop, I'm just going to get it to print out however I want to do it. So I've got it saying print the value of x. So that'll be 1 times, 2 times, 3 times, etc. Times my chosen whatever the chosen number is, and then the result of that calculation. So if I run that, you can see it asks me for a number. So if I say 5, it'll say 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. So you may have had the print statement slightly differently, but the key thing here is that you want to multiply your value of x, which is iterating through the numbers 1 to 12, by whatever your chosen number is, and then print out the result for each one. For task 2, I ask you to write code that sets up a new list called pen called team with our names in there and iterates through the list saying hello to each team member. So I've set up a list here called pen called team, use the square brackets to denote the list. So I put in our names here as strings, and then I'm iterating through the list using a for loop. So I'm iterating through the actual elements of the list. So I've called it for team member. Remember, you can call it anything you like, but something is easy to refer to. So that will represent each item in the list. So for team member in pen called team, print hello, followed by the team member. So if I run that, you can see it says hello to us. Then for task 3, I asked you to write a piece of code that asks the user to input a number, and we'll keep asking them to input a number until it's more than 100, or if the user enters 0, the program will exit with an appropriate message. So again, capture the input here, store it in user number, and then within a while loop that says whilst that user number is less than or equal to 100, we also need to check to see if they input a 0. So if the user number is 0, then I'm going to print exiting program and then use a break to get out of the loop. Otherwise, then I'm going to ask you to enter a number again. And so if I run that, you'll see, please enter a number 3, please enter a number 6, please enter a number 102, and we exit. And similarly, if I'd have run that and typed in 0, it'll say exiting program. Then for task 4, again, a little bit more challenging, and well done for those of you who worked out that. Again, we need our old friend modulus to help us out here. So write a piece of code that counts up day numbers from 2 to 364 inclusive, and displays a message giving the day number every second day, and additionally displays a reminder to go shopping every 4 days. So I've got a for loop here, which is for day in range, and I'm going to start counting from 2. Now I want to go up to and include 364, so I need to make sure I've got at least one value above that. So I put 365 here. You could have included 366 as well. And then goes up in increments of 2. So it will start at 2 and it'll go up to but not include 365, which obviously it'll never count 365, but it would go above that, and that will count, and that will stop the loop. I want you to print the day, followed by the day, and then also if it's every 4 days, in other words, if I take the day number modulus of 4 and the remainder is 0, in other words, it's one of the 4th days, then I will print this message as well saying go shopping. And so if I run that, you'll see exactly that happens. Any questions about any of that? No? So if you, I know a number of you wanted to share your code because you may have done it slightly differently, and that's great. So if you have done that and you're happy to share your code, please do share your solutions so other people can see them as well. Okay. So we've talked a little bit about lists so far. Lists are really, really useful, and you'll use them a lot within your programs because they're really useful ways of being able to store multiple items of data. Sorry, somebody's unmuted.
Dan, can you make me co-host again?
Yeah, I forgot about that. Sorry. Thank you. Yeah, so lists are a really useful ways in which we can store multiple items of data. So you'll be using these a lot. So let's have a look. So if we wanted to define a new list that started off empty, for example, we can use this format here. That just says I've got a new list called my empty list, and I just use the open and close square brackets to say here's a new list, but there's nothing in it yet. I may want to define a new list and I may want to put some values in to start with, and that's also fine, in which case we do exactly the same thing, only this time we give it the starting values that we want. So in this case, the numbers 3, 4, 7 and the string hello. If I want to add an item to a list, we can use the append function of the list. So to do that, we use dot notation, which basically means you're using the function within the list class. And we'll come on to more about that when you get to object-oriented programming in a couple of weeks. But essentially, we use the dot notation. So my list, we've declared as a list. Python knows it's a list because we've set it up in this way. So it's automatically cast as a list. So what because it's now a list, there are certain functions that are associated with lists, and we can call on those functions by using dot notation. So my list is a list. So if I put my list dot, I then have access to all of the functions that are associated with lists. And one of those functions is the function append, which basically just means add an item to the list. So if I put dot append 2, for example, it'll then print my list. It'll have added the number 2 to the end of the list. Now, append will add by default to the end of a list. And remember that the order is important in a list. It is an ordered collection of objects. So I can use that to append any item I want into that list. Now, we can also use another function associated with lists called the extend function. What the extend function does is it allows us to add multiple items to a list. We can give it a list and then give it another list and say add that list onto that list and make it one big list. So let's imagine we have a list called my list, and then what I can do is I can say extend that list using the dot extend function, and I'm going to extend that with another little list that I've given it here called 6, 7, 8, 9 and 10. And then if I print my list, you'll see we end up with one big list that's added, not only got the original 5 values, but has also added to it, added to it the values 6, 7, 8, 9, and 10, which I put in the extend function. Now, we said that lists are ordered, and that's important. And what that allows us to do is it allows us to refer to specific items in a list according to their index, where it is within the list. Now, as I said to you before, in Python, as with most programming languages, we start counting from 0. And here's an example that of something where if you're not used to programming, this will take a little while to get your head around. So if I want to refer to the first element of the list, that has an index of 0. So if I want to refer to the third element of a list, that has a value of 2. We start from 0. So it can take a little bit of getting your head around, and I can guarantee you will make mistakes initially where you'll refer to the third element of a list, or think you are, by putting the number 3. That's not correct. You always need to subtract 1 from whatever index position you're thinking. So if we take this example here, in my list, we've got the numbers 3, 4, and 7, followed by the string hello, and then the number 2. So 3 is at position 0, 4 is at position 1, 7 is at position 2, hello is at position 3, and 2 is at position 4. Now we can refer to individual items in the list by using square bracket notation. So we can refer to the list by its name, my list, and then use square brackets to give an index number. So if I put print my list, open square brackets 2, close square brackets, then that will return the value at index location 2, which is the third element in the list. So in this case, the number 7. Okay. We can also use negative indexing to refer to an item based on its position from the end of the list. So if we were to give it the index of -1, that will give us the last item in the list. Similarly, if we give it the value -2, that will give us the penultimate item in the list and the next to last item, etc., etc. And of course, that doesn't start from 0 because 0 is used for the first element, just for that extra little bit of confusion. You probably won't use negative indices as much as positive indices, but it's worth knowing that you can do it, particularly if you need to refer to the very last or penultimate items within a list. So here, if I said print my list -2, that will give me the next to last entry, which would be hello, and that's what will be printed. We can also give our indices in terms of index ranges. So rather than just refer to one item, we can refer to multiple items. So if our list is 347 hello 2, we can say print my list 1:3. What that means is give me everything in the range from index 1 to index 3. Now, here's another example of where within a range, you are not including the limit number. So here, if I say print my list 1:3, that means print everything from the second element. Remember, the second element is index 1, up to, but not including the fourth element. So that will pick the values 4 and 7, the second element, index 1, and it'll also take index 2, 7, but it won't include index 3, which is hello. So it'll print 4 and 7. So you've got an extra little block there to think about. You're not only having to remember the index elements are sort of one off from what you think they might be, but also remembering that the upper limit of the range is not included. We can also use slicing here so that we can specify, rather than putting a hard a limit on the upper or lower bound, we can say give me everything up to, or give me everything from. So if I'd say print my list and then simply :2, so no initial value here, then that will say print everything but not up to, but not including, remember, the third element, the index, the value of index 2. So in this case, that would print the first element, value 3, and the second element, value 4. But it wouldn't print the index value 2, the third element, here, 7. And I can do that the other way around as well. I can say, give me everything from this point onwards. So if I say print my list 3, and then leave the rest blank, it'll give me everything from the fourth element onwards. So that is including, remember, when you're going from something, is including the lower limit. So that would be from index value 3, which is the fourth element. So hello onwards, and in this case, it's just 2 values. So hello and 2 will be returned here. So it takes a little bit of getting your head around that, and sometimes even I have to stop and think about it. But it is useful to use this in that way and to refer to them in that way. So it's a little bit of a stumbling block, but you will get there. And if in doubt, remember you can use the interactive console just to print. If you're not quite sure what's going to happen, just do a little print command on your list slice and see if it prints what you think it should, just to make sure that you've got that right. We can also use a couple of other really useful functions. We can use length and pop. Sorry, remove and pop, I should say. So these are ways in which we can remove items from a list. Now, remove removes a specified item from the list. So by using the remove function, you say, find that value in that list and get rid of it. So here, if I wanted to remove the word hello from my list. I can say my list.remove, and then I give it the value that I want it to remove, hello. And if I print my list, it'll print that list without that value. I'll put that list back, and then we can try another method, which is pop. So what pop does is it removes an item based on its index by where it is in the list, not on its value. So if I were to say my list.pop3, it'll remove the value at index 3, which you remember is the 4th item in the list, which is also hello in this case. So both of these will get rid of the word hello from the list. If you don't specify any value in the pop function, then it'll simply remove the last item in the list. And that in itself is quite useful when you just want to remove the newest value for whatever reason. You can use .pop, open close brackets without a number, and that will automatically just remove the last item from the list. Another thing that's quite useful to do is to check for whether something exists within a list. So we can do that using the in command. So let's imagine we have our list 347 hello 2, and we want to check whether the number 2 is in that list. So I can use an if statement here, which says if 2 in my list. And what that will do is that's again an operation that will check and will resolve to a Boolean. Either 2 is in the list or it's not in the list. So it'll resolve to either true or false. So it'll go to the list and it'll check to see if value 2 is in that list. If it is, then it'll print already there. And of course it is in this case. So it's there. The in command you'll find very, very useful, and we'll show you examples of how that's useful as we get into some of the more advanced methods later in the course. Now, you may also want to take a copy of a list so that you can do something. You want to take a copy of it so you can do something with one list, one copy of the list, and leave the other list standing, or do something else with it. Now, it might be tempting to copy a list by saying this. So let's imagine we've got my list here, and then we say copy of my list equals my list. That won't actually work as expected. Does anybody think what might happen if you were to do that?
Does it not know that it's a list at that point because it's not a predefined?
No, it'll know it's a list because you've said my list equals, and you've used square bracket notation. So it's clocked that it's a list and it's stored it as a list.
Does it just rename it?
It's a reference to the list, so they're basically the same thing.
Yes.
So any action to one will affect the other.
Exactly so. So if you say another name for a list equals my list, it'll say, oh, right, they're equal. So this is just a different name for my list. So if I were then to change copy of my list and say I removed the word hello, it'll also remove it from my list because there is only one list. You haven't taken a copy. All you've done is said, this is another name for my list. Now that's normally not what you want to do when you want to copy a list. Normally you're taking a copy because you want to have a second copy of the list that you can play with in a slightly different way whilst leaving the other copy as it is. So the way we do that is we use the copy function. So when you want to create a copy of your list, you'd say copy of my list, or whatever you want to call your copy, equals the name of your list that you want to copy, and then use the .copy method. And that will then take a copy of that list as you would expect. It will create a brand new list that also says 347 hello 2, but you can now work with those two lists separately. So any changes you make to copy of my list won't affect your original list. Very important. It's a very easy trap to fall into because you would think instinctively using the kind of the language that you're used to in Python, that saying copy of my list equals my list will create a copy, and it doesn't. You need to use the .copy method. Another super feature of Python is something called list comprehension. Now, list comprehension is a really, really useful feature of Python that at first can seem a little bit hard to get your head around, but when you do, it's really, really useful. Let's look at how it works through an example. Let's imagine we've got a list of numbers and we want to set up a second list which contains all the numbers of the first list but doubled. Okay, I don't know why we want to do that, but let's imagine we do. So here's one way we do it. We can set up a list called list A, and I've got the numbers 1, 2, 3, 4, and 5. And then I set up a new empty list called list B. And then what I do is I iterate using a for loop through each of the elements in list A. And I say, so for number in list A, and then I want to append to list B, that number doubled. Okay. If I print that, that will give me, print that second list. We'll see that that second list now is 2, 4, 6, 8, 10, which is what we want. So that will work. But there's a better way of doing it. And that's using a list comprehension. So we set up list A in the same way, 1, 2, 3, 4, 5. But what we do is we set up list B here using a list comprehension notation, which is where we use the square brackets in order to indicate that this is a list. But rather than giving the specific values in the list, we give it essentially a for loop within that statement. So we say here, we say x times 2 for x in list A. So let's unpick that. What that means is for each x, or whatever you want to call it, in list A, for each of your elements in list A, double it and make the list made up of that. Then when you print list B, you'll see that it's done 2, 4, 6, 8, 10. So for each x in list A, take x times 2, give me x times 2. Similarly, if you wanted to give the opposite, you wanted to list B to be half of all of the elements in list A, and you can say x divided by 2 for x in list A. You'll see some further examples of list comprehension as we go through the course. You can also include conditional logic in it, for example. So you can use, you might want to say, double all the numbers that are over 3. So you could say x times 2 for x in list A if x is greater than 3. So you can use a combination of for loops and conditional logic within that those square brackets, so that you're essentially, it's a shortcut that you're creating a list all in one go by getting it to make up that list. Now, particularly, obviously it's nicer to write that just from code, but also when you get into really complex programming, you want to think about computational efficiency, and it's much more computationally efficient to get Python to do this all in one go automatically and set up the list in that way using a list comprehension than it is to iterate through and each item in the list, which when you have very large lists can get very costly. We also mentioned dictionaries before. We showed you a little bit about dictionaries. Dictionaries are really useful ways to store values associated with an index value. So we might want to store, for example, various information about a patient in a dictionary, by their patient ID, name, year of birth, readmission, whatever it might be. If we set up a dictionary, we saw before that we can set up a dictionary using the curly brackets, and then for each element in the list, we have an index, which is the name of the piece of item that's being stored, that's how we'll refer to it, and then a colon, and then the actual value we want to store against that index. So if I print that dictionary, which I called my patient dictionary, we'll see this top line here. It'll come up patient ID 167. 4234, name, Bob Smith, year of birth, etc., etc. We can easily grab a particular piece of information then from our dictionary by using the name of the index that we want. So then we can say in square brackets, so print my name, my patient dictionary, and then if I want the name from that dictionary, then I can just give in square brackets and inverted commas the name of the index, in this case name. And if I do that, it'll print Bob Smith. So it prints the value that's associated with name. So here we said Bob Smith was associated with name. We can also change dictionary values really easily. So let's say I wanted to change the year of birth from 1961 to 1960. I can refer to that element by saying, by giving year of birth in square brackets. And then I can say that equals 1960. And if I print that dictionary again now, you can see it's changed the value to 1960 in the dictionary. Or I can add new key value pairs. We haven't got month of birth in there. I can add that in really easily, again, using the same notation. So I can just create a new key value pair simply by referring to one that doesn't exist. So here, if I say my patient dictionary, and then I say month of birth, well, that doesn't exist yet. Python will automatically then set it up, and it'll set it up as being this is the index, and whatever value we're passing in will then be the value that's associated with that index. Similarly, I can delete an entry that we no longer need, a key value pair that we no longer need, and I can use the del command to do that. So if I say del my patient dictionary, and then I give it the index readmission, it will then remove the key value pair readmission from that dictionary. Also mentioned earlier about sets and tuples. Now, we won't be covering those in detail today, but you should read about them, because although you won't use them as much, you will be using them at various parts of the course and likely in your programming going forward. So on your slides, you'll find 2 links here to Mike's wonderful Python healthcare website, which has huge amounts of information about all things Python related to healthcare. And these 2 links in particular will take you to a section talking about sets, and a section talking about tuples. So do make sure you have a read of those in your own time. Okay, so we've run over by 9 minutes. Apologies for that. We'll now take a break. When we come back at 1:30, the first thing you'll actually do is to be working on the next exercise, which is the Python Prog workbook 3 in Jupyter Lab. So let's just take a quick look at that. I'll also, and I promise I'll remember this time to actually paste the questions for those of you not using Jupyter Lab. So you've only got 3 tasks on this one, but they're a little bit harder. So the first task, I want you to write a piece of code that asks the user to name their 5 favorite things in the world in descending order, and then stores them in a list, removes the last 2, and prints out the top 3 to the user. Then for your second task, I want you to write a program that asks the user to input 10 numbers, which are stored in a list. Then, using a single line of code, create and print a new list that contains only numbers that are both odd and less than 100. And then for the third task, I want you've crashed on a mysterious island. After several years, you walk into a cave and discover mysterious writings on the wall that associate numbers with the surnames of Pencil team members. 4 being Chalk, 8 being Allen, 15 being Monks, 16 being Pern, 23 being Salmon, and 42 being Harper. Perplexed by this, you decide you should probably write a piece of Python code that stores these entries in a dictionary. Frankly, that's the first thing I'd do. And your dictionary is called candidates, and which allows the user to input a number to find out the corresponding candidate surname. So the user inputs the number 8, then they will find the number, be printed with the entry Allen. If the user inputs a candidate number that doesn't exist, the system should warn them of this and allow them to input again. The system should keep asking the user to input candidate numbers until the user types -1, at which point the program will say goodbye and terminate. Okay, so those are your 3 tasks, a bit of practice with lists, list functions, and dictionaries and dictionary functions. But do now take a break for the next 50 minutes. Resume at 1:30, but you'll be going straight into these exercises. And I'll give you 40 minutes to do that. So we will come back onto Zoom at 2:10. Okay, so make sure you stretch your legs, have some lunch, resume at 1:30 with this exercise, and we'll come back on Zoom at 2:10. And if you need any help, as I say, as you have been doing, speak to your peer support group or shout for a mentor. Any questions about any of that? No?
No.
Great. Sorry.
I said no.
Oh, good. Excellent. Okay. Take a break, everyone, and see you this afternoon.